This is MetroCycle, a fully integrated operating system built in just 2 days using notional city bike ride data. This demonstrates how creating a digital representation of your organization through an ontology can transform raw data into actionable insights. This structured framework acts as a refinery for artificial intelligence, providing the context and logic needed to turn data into meaningful results. This enables smarter decision-making and unlocks real innovation and efficiency. Here you'll see notional data generated by AIP, paired with all the data from the rides from City Bike in the city of New York, cleaned through a pipeline adding financial details, giving you all of your objects you need to create an operating system for a ride-sharing service. This allows us to see a generation of our fleet digitally. We can see we're already filtered down to a station. We'll come back and see our total number of bikes that we own. We'll go back to Hoboken, and we'll see that we got CB155 sitting there. Let's open the images to simulate that bike being returned by a customer and them taking a picture to confirm it's done. We've already got it set to ask AIP if this bike's locked in a safe place, and we can see that it is not in a safe place, but there's another element to this that we want to know, and that is, does this bike need repair? And what this is meant to be is a generation for us to create a work order if this answer is yes. So we'll see down below that this bike isn't in the worst of shape. It's got okay tires, chain, brakes, seats, but a closer inspection is recommended. So we'll come over here and we can see that there's a work order for CB155, but it's at Hoboken Terminal and it's not assigned yet. So let's go assign that to Ashley Bradshaw. We can see all our open work orders here and a way to interact with them within the system. We'll click open AIP work order summary after we click on that object, and we can see just a quick breakdown on what that work order is. Obviously, if this was more in-depth, there would be more information. If we click AIP troubleshooting, we'll go over here and we will type in, what should I check on bike for a tune-up? Now this is going to reference an index document that references our standard operating procedures internally. And it's going to give Ashley a quick breakdown on all of the things that she should be checking on that bike to constitute a tune-up. So we'll close that because there's another part to this. That bike is at Hoboken Terminal and we need to get it to the shop. So we can see we have a bike that needs to be moved. We can see we've got 3 transport trucks right now. And you can see how if we had more time, there would be a AIP element to this as well, where we would intuitively assign this, but let's assign it to CVO1 right now. Now we can see that he has something that he's got to do, and we can complete that move, simulating that he's now done that, bringing that bike back to the shop, making sure that Ashley can get that tune-up started. We can now see that there's 279 instead of 280 bikes at Hoboken Terminal. And if we click on shop, we can see we have CB155 in the shop now. So we'll go back over to transport and we'll see that we've actually created a proof of concept external to the ontology called an OSDK, where these are pumped to the transport drivers on their phone directly so they don't have to sign directly in. We can click over to employees now and we can see all of our employees, we can see their information, and we can actually see their time cards as well. So we can click in to verify certain things like where was somebody on a certain day. We can also have a portal for open positions as well. When you have all this together, you can now create your total ontology and top-down view of your company financials. So you got your labor expenses, you have your work order expenses, and you got your bike purchase expenses. But you get your membership revenue streaming through and your individual ride revenue coming through to get a live view of your net profit over time. And not only that, but we can now generate how much each station is making in real time, and we can allocate those bikes back to those stations. We were also able to develop some cool features behind the scenes, like some models, but the real power of this is the ability to develop an operating system over the course of 2 days. This was voted by our peers as the championship workflow of DevCon. This achievement would not have been possible without the exceptional talent and dedication of the SQL Cache team. Bing Liu, Jennifer Morale, Jimmy Vu, Rob Fender, and myself, Peter Vignew, as well as our incredible Palantir lead, Danny Evans. A special thanks as well to everyone who contributed their expertise and creativity to the PalPhone feature. DevCon was an absolutely incredible experience, showcasing the power of collaboration and innovation, and I'm already looking forward to the next one.